The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, we are back with another episode of Cosmic Catastrophe. I am your host, Diamond, from the Oppenheimer Ranch Project. My lovely co-host, Leah Shaper, is joining us once again this week. We missed you.
Hello, it's good to be back.
And your mic is on. Awesome.
I know, right? And I'm not echoing either. That's amazing. How did that happen?
Oh, good news. Today, we're going to continue the discussion that is hitting the airwaves. The paper just came out 3 days ago on Fennoscandian tree rings. And the claim is that the medieval warm is actually not warmer than today. Today is warmer. Now, there's a couple of problems with that, and we'll go over it. But before we get to that, the title of the show is The Geologic Evidence of Recurring Climate Cycles. The past is the key to the future. And we're going to dissect this claim in great detail, and it should be a fun ride.
Yeah, I'm looking forward to tearing this paper apart because it's really garbage.
Yeah. Now let's jump into it. We're going to share this screen here, and those of you listening on the radio, we thank you for participating at Revolution.radio, the #1 listener-supported radio on the internet, and it is supported by you. So go make a donation there at Revolution.radio. Can you see the screen?
Yes.
All right. So the first thing I want to start with is that this is the last 5 million years on Earth. In the last 5 million years on Earth, there have been hundreds of major climate change events in the order of tens of degrees Fahrenheit. And there have been hundreds of them. And they happen every 40 to 100,000 years at a very large scale. Nothing like the climate change they're talking about at the IPCC, which is just a few degrees. It's nothing like that. These are catastrophic shifts in climate that have been happening nonstop for 5 million years. Yep. And the media wants to claim that now it's your fault, and then if you pay taxes, you can change this graph somehow.
Somehow you can your effect can be more than the effect of the sun.
Yeah, it's not you, it's not CO2, it's the sun, and it's also the orbital dynamics of the solar system, which we'll get into in the second half of the show.
Yeah.
Now, the paper that came out it came out August 2nd, so that's just 3 days ago. Fennoscandian tree ring anatomy shows a warmer modern than medieval climate, and everyone in the science community picked it up because it fits the narrative of man-made global warming, and we're, ruining the planet, and it's our fault. The only problem is, if you simply read any of these articles, within the first few paragraphs, there's a caveat that this data may not necessarily be true.
Well, there's that, yeah, and then it's worse than that. It's based on premises that are inherently problematic. Like there's this sentence in this article about this paper that says, it's a little paragraph. This has long been a puzzle, meaning that the proxy data that we've had in the past portrays this period as being warmer than modern times. This has long been a puzzle because there is no known physical explanation for such exceptional medieval warmth. First of all, that statement is a lie. That's not true. There is a known physical explanation.
Yes.
And then it says, climate models are therefore unable to simulate it and instead show only moderately warm temperatures for the medieval climate anomaly. So basically what they're saying is, because we don't know what the explanation is, our climate models must be right. That's completely circular logic. That's nonsense. Like, who does a study like this and thinks that this is legitimate? It's completely insane.
Well, additionally, it's a model they're using, which has nothing to do with the actual data or proxy data, which is based on factual observation of things like ice cores.
Right.
And there's other issues with tree
There's
rings.
so many other issues on this.
We're going to get into a little mini course on how they use tree rings and what tree rings mean. And so when we do discuss that in just a few minutes, it's going to put more, it's going to add more problems to this paper because, and they say it right in here. First of all, it says support for the climate models. Previous reconstructions are based on the width or density of tree rings. That's basically how they look at tree ring data. You look at the thickness, the width, or the density. And you can come to two conclusions. Either it's temperature related or it's water related. It has to be one of the two things, but neither of them exclusively. So just because you have small tree rings for a number of years doesn't mean it's hotter or colder. It doesn't necessarily mean there's more water or less water. It could be a factor of both of them. So there's no way to look at a tree ring and know if it's hotter, and there's no way to look at a tree ring and know if it's wetter. You have to guess. And they use dendrochronology to date things, not to tell what the temperature was. So they mostly use dendrochronology because it's accurate in dating things back a few thousand years, because we have this data set for dating things like wood. So we could say, oh, that Mayan ruin is 2,000 years old based on the wood we found in it. It says it's not very good for temperature.
Right.
So it's all guesses. But what is good for temperature is what we've been using for decades, which is ratios of different isotopes of different elements, which can be directly connected to temperature.
And that's from ice core data.
Exactly.
So, and then you have to use those two things.
You can get it from other things like lake sediments and stuff. You can get it from other things.
Well, that's another thing here, because then they talk about how, well, what we did instead of using tree rings is we used the cell wall thickness of the cells. Okay, but they don't explain why that is an accurate measure of temperature. They fully acknowledge, at least in the review of this paper here, and I haven't read the whole paper because I could only get the abstract. I would have loved to really look at it and pick it apart there, but they say that, oh, well, the dendrochronology isn't definitive. So instead we use cell wall thickness. Well, obviously cell wall thickness is going to be somehow directly related to the density of the tree rings, but they don't explain why their cell wall thickness is a better measurement for temperature at all.
And there's certainly probably other hundreds of factors like plant physiology, nutrients, blah, blah, blah. It goes on, disease, etc., that could affect cell wall.
Right. I mean, this is like, I can't even believe that this is called science. It's just such garbage.
It's filled with lots of assumptions. And they even give a caveat here. Like I said in the third paragraph, this is like according to the Swiss Federal Institute of Forest, Snow, and Landscape Research, that tree ring width and density are very much dependent on temperature, but sometimes other factors play a role in how wide or dense a tree ring gets.
Exactly, right? So they acknowledge that, but they don't even bring that into like the cell wall thickness concept, right?
No.
So and then add to that the fact that this is only for one specific region of the world, where, maybe when we get into talking about, let's say, obliquity of the axis of the Earth, like the variability in temperature from one latitude to another can change very significantly in relation to global average temperature. So
during the medieval warm specifically, we have very high resolution proxy data that shows that there was only warming in certain areas, very limited areas. Other areas just stayed the same. And we'll show you all that towards the end of the show.
Right.
Yeah. So you can only get the abstract now because they want you to pay $30 to get this paper.
Yeah, I know. Well, and it's so funny because the second that I went to go look at the actual paper, I was like, I know this is going to be behind a paywall, right? Because they can't have other scientists who don't have institutional access to these journals picking this paper apart. So of course,
and like you said in previous podcasts, that when you read the abstract, and then you read the paper, it often contradicts itself.
Yeah, that happens a lot. Because the abstract is written, at least these days, the abstract is written for the media. It's literally written for a narrative. So
yeah, if you're giving a talk at a local like Geologic Society of America meeting, the only thing they publish is your abstract. You don't even need to write a paper.
Yeah. It's just so tremendously sad, right? Because sometimes the lie is even about the statistics, right? So an abstract, for example, might claim that some result is statistically significant, and then when you actually go look at the math, it's not.
So
It's really pathetic.
Steve Malloy over at Junk Science, he is the founder of junkscience.com. Perhaps the most influential climate science contrarian, according to Nature. Trump's EPA transition specialist and a bunch of other stuff. He worked on biostat. He's pretty much a top climate scientist, one of the top in the world. And he doesn't put up with any garbage. And so he tweeted yesterday, sorry, but tree rings cannot be used to know the past global temperature to a precision of 0.1 degrees C. That's just insane. Just read the sentence. How is that possible? Mm-hmm. Past the fact that tree growth depends on many factors, 90% of modern U.S. temperature stations aren't even reliable to within 1 degree C. So there you go. And again, we'll get into this, but he says we can surmise that the medieval warm period was warm or as warmer than today because of things like grapes growing in Britain and the Vikings settling Greenland.
Right. Things that are not happening now.
And impossible. In fact, we're going to get to the specifics on the grape growing regions, the elevations and stuff like that in a moment.
My God, we can't even grow grapes where we are.
But I keep trying.
Yeah.
So here is the data that goes back 4,000 years. That red dot on the right side is the current temperature on Earth, and it shows many different cycles of warming and cooling going back 4,000 years. In fact, the medieval warm was warmer than today, not by much, 0.5 degree C. But the Roman warm was a full degree C or 1.5 degrees C, even warmer than today. And the Minoan warm was perhaps 2 or more degrees C warmer than today. That is very significant.
Yeah.
And what that tells you is that in the last 5,000 years, there has been a rapid cooling, and that the modern warm is nothing more than the next spike in a downward trend in what is the end of the interstadial. Does that make sense?
Yeah.
Here's a bigger graph that shows you since the Holocene warm. This is the last 10,000 years. And the green line isn't the average temperature, which it looks like it is. It's the obliquity of Earth.
Yep. And
this temperature is coming from the northern hemisphere, which is most affected by the tilting of the Earth. And you can see
obliquity basically meaning the angle of the axis of Earth's rotation relative to the sun.
Only changes a few degrees. We'll talk about that in the second half. We'll do a little, I have a little video about it.
Oh, good.
But if you look at since the Holocene warm, what you can see here's some green stripes, is that there are cycles of regular periodicity happening every 1,000 years of warming and cooling. And many people call these the Bond cycle. And you can see these cycles go back and they last for the entire interstadial. And none of them are caused by humans. So what the audacity of climate scientists and the media to claim somehow a trace gas and cow farts is completely I mean, I just don't get it.
Well, and then we have some other graphs too that show the lack of relationship between CO2 and temperature from the Holocene era. It's
exact opposite. Here's CO2 on the bottom.
Right.
So as CO2 is rising, the temperature's dropping.
Right. Right.
There's no correlation.
And it's the same thing in the Holocene. You have CO2 dropping while temperatures are rising.
Exactly. All right, so let's talk a little bit about tree rings and what they tell us. And look, they have a picture of Mesa Verde.
Yeah.
This is how they specifically date these ruins, because there was lots of wood left in the building.
Yeah. So
the underlying pattern of wide or narrow rings, they record year-to-year fluctuations in the growth of the tree. That's true. Mm-hmm. So the patterns, therefore, often contain a weather history at the location that the tree grew. In addition to its age, in dry environments, such as the Middle East or U.S. Southwest, tree rings typically record wet or dry years because there is a profound effect on the growth in those regions. In cooler areas or higher latitudes towards the poles or even higher elevations, tree ring widths are often a proxy for extreme temperatures. whether hot or cold. Does do you agree with that?
I don't know. I don't know if I can actually evaluate that statement.
Well, it's based on observations of the recent few hundred years and known climate and weather models. So if you have the climate weather data and you look, you can confirm this with the trees. But it is not always the case. It's just a general idea. And so they're basing their entire assumptions on the cell wall thickness and the tree ring thickness based on that assumption that they were at a higher latitude. Therefore, the tree ring thickness in the Fennoscandian record must be due to temperature and have nothing to do with the weather. But here's the big problem with that. That the weather was rapidly changing every 1,000 years, wet and dry. And these spikes are driven by the shutdown of the ENSO cycle. So when we have strong El Niños, what happens in some continents is it becomes very dry, like North America. And when the ENSO cycle shuts down, deserts like the desert Southwest become wet. And areas like the Sahara, Northern Africa, which is like the biggest desert in the world, 6,000 years ago, when the ENSO cycle was shut down, it was a rainforest. No one even knows that. Yeah. So the problem is that the climate is always changing. So the Fennoscandian climate would have had a response to climate effects due to this cycle.
Right.
And so the tree rings don't necessarily have anything to do with temperatures. They could have everything to do with temperatures and also droughts and deluge. That makes sense, correct?
Yes, absolutely. I was also reading that when we have that kind of shift, let's say, right, when the Sahara becomes wet again, it's also due to this migration of the intertropical convergence zone, right, which is off the coast of, well, it'll either be off the coast.
We'll cover that. We'll cover that in the second half when we go over this Holocene paper.
Yeah.
Let me show you the. Yeah, so here's we've got the Holocene climate optimum, which occurs from about 9,000 years ago to about 5,000 years ago. And that's when the ENSO cycle was basically shut down.
Yeah.
We have an extremely wet Sahara. So that's when Lake Chad became Super Lake Chad and was an inland sea. It gets extremely wet here in North Central Asia, which is now typically dry. And so once the ENSO kicks in, things change and everything here dries out, which was once wet.
Mm-hmm.
Yeah. So we'll get to that in the second half. But I wanted to just talk about some of the evidence that the medieval warm was warmer than today. So first, let's dive into the history of the medieval warm. It was a time of warm climate from about 900 AD to 1300 AD. Which is when Mesa Verde flourished, the exact time frame.
Mm-hmm.
And all of the people here in the desert Southwest. And when global temperatures were apparently somewhat warmer than the present. Its effects were evident in Europe, where grain crops flourished, alpine tree lines rose, and many new cities arose, and the population more than doubled. The Vikings took advantage of the climate amelioration to colonize Germany. Or Greenland, I mean.
Germany.
And wine grapes were grown as far north as England, where growing grapes today is now not feasible, and about 500 kilometers north of any present vineyards in France or Germany. So that is a significant climate shift.
Yeah.
Grapes are presently grown in Germany up to about 560 meters. But from about 1100 to 1300 AD, vineyards were extended up the slopes of mountains to 780 meters. And that's implying temperatures were much warmer, up to 1.4 degrees C warmer than now. We also have evidence that wheat and oats were grown around Trondheim, Norway, suggesting climates in Norway were at least 1 degree C warmer than present, because they can't grow that today.
Mm-hmm.
Elsewhere in the world, there were prolonged droughts that affected the southwestern U.S. at the end of this warming. And Alaska was warm at the same time. So, and at the end of the warming, which is 1300 AD, there wasn't really a single person occupying the desert Southwest, pueblos, or cliff dwellings. They had left.
Yeah, too warm.
So it must have been because they were used to living out here, which
Yeah.
is sparse to begin with. It must have been horrific.
Yeah, it must have been super warm and super dry.
Well, and in 2001, the San Juan actually dried up in Pagosa.
I didn't know that.
Yeah, it was the lowest recorded in modern history. It went to 14 CFS or 7.
Wow.
Yeah, all the fish died. But we had a
Yeah.
fish kill 6 years ago here when it
Yeah.
got very low.
Yeah, it got very, very low. I mean, the San Juan didn't get quite that low, but the Rio Blanco certainly did.
The tree ring data suggests that it was 13 years of no rain.
Yeah. Wow.
That is bad.
That's very bad.
Yeah.
Yeah.
Surface temperatures in the Sargasso Sea were 1 degree C warmer than today, and the climate of equatorial East Africa was drier from 1000 AD to 1270 AD. An ice core from the eastern Antarctic Peninsula shows warmer temperatures during this period as well. Now let's talk about good proxy data. Oxygen isotope studies in Greenland, Ireland, Germany, Switzerland, Tibet, China, New Zealand, and elsewhere, plus tree ring data from many sites around the world all confirm the presence of a global medieval warm period. So cherry picking the Scandinavian record negates all these dozens of other places. I mean,
Right.
it's insane.
Well, and it's beyond cherry picking because not only do they cherry pick a place, but then they only utilized one set of data, which may have nothing to do with climate. It's absolutely ridiculous to ignore all of this and just brush it off.
Our friend Willie Soon was livid at the position of all these people. Back in 2003, Willie Soon and Baluinas, don't know how to say that, they found that 92% of 112 studies on the medieval warm showed physical evidence that the medieval warm period was warm.
Yeah.
That's pretty high. Only 2 of 112 studies showed no evidence, and 21 of 22 studies in the southern hemisphere showed evidence of medieval warming when many of the proxies show no warming. So something happened at this time frame where there was warming in places around the world.
It's very interesting that we're in this moment where there's kind of this revisionist history about climate, right? Like we're getting the narrative, oh, it's warmer than it's been in 120,000 years. And oh, by the way, the medieval warm really wasn't that warm.
Now, at the same time, we got some tricks going on with the data set in the United States, and we've got the hockey stick trick.
Mm-hmm.
And the reason evidence of the medieval warm period was, I mean, the evidence is overwhelming. 95% of the papers are showing it. And the medieval warm period was a global event so widespread that one wonders why Mann et al. In 1998 ignored it completely. And they eliminated it from climate models. Over a period of many decades, several thousand papers were published establishing the medieval warm period from 900 to 1300. And then the subsequent Little Ice Age from 1300 to 1915 as obvious major global climate change. Thus, it came as quite a surprise when Mann et al. In 98 concluded that neither the medieval warm period nor the Little Ice Age actually happened on the basis of a tree ring study. So see, you can use tree rings to lie about the climate.
And that's the position that the IPCC picks.
Yeah,
Let's pick this one little paper in with all of this other evidence.
The IPCC picked Mann's hockey stick to override all the facts on global climate. There it is. There's his hockey stick data. There's no Little Ice Age. There's nothing warmer than now. Look at us. We're burning up. Never been warmer than now. When in fact, this is the actual data. This is surface temperatures of the Sargasso Sea, which can be easily measured using isotope data. And you can clearly see that it gets warm and cold quite drastically, unlike what the IPCC wants to show you, which is this garbage concocted graph based on tree rings, not on temperatures. It's almost embarrassing.
Almost? It's highly embarrassing.
The Mann et al. Hockey stick temperature curve was so at odds with thousands of published papers, including the Greenland GRIP ice core isotope data, sea surface temperatures in the Sargasso Sea sediments, and paleo temperature data, and other tree ring data. It's insane. And when we get back, we will discuss the facts about what's happening on Earth and what we need to do about it.
Listening to Revolution Radio at freedomslips.com. And we'll be right back after this message.
Who owns you? If you're not in control, then someone else is. Join me, Ivy West, for Voices on the Wind, Saturday. I discuss government, health, metaphysics, suppressed science, universal mysteries, little-known incredible facts, alternative energies, and even more than you can imagine.
There is blood on the wire.
Won't you join us on Revolution Radio Saturdays for Voices on the Wind with me, Ivy West.
There are lives in the balance, people under fire, children at the cannons.
Because if your head's in the sand, your tail is a target.
Thank you for listening to Revolution Radio, freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio!
The Secret Kindergarten is here for the young children of the world. The best program on the radio for kids, dealing with the most important topics in the whole universe. Fairy tales, music and movement, numbers, plants, animals, fun, colors, insects. Take care and cast your ears out to catch a story from the world of other young things. Reach out, up, under, and over. Sing a song. Talk about feelings. Just remember the magic word. The magic word is no. Step on into the Secret Kindergarten. Saturdays, 1 p.m. to 3 p.m. Eastern Time, right here on Revolution Radio.
Join me on the Brian Rouge Show on Revolution Radio, Eastern Standard Time, every Tuesday night from 6 to 8. We talk about the four most vital things, in my view, affecting all of humanity. Number one is UFOs and aliens and their agenda for the advancement of humanity. Number two is the Jewish establishment's control over all aspects of human civilization. Number three, the truth about Adolf Hitler, how he was the opposite of what we've been told. Number four is advanced ancient global civilizations. Join me on the Brian Rouge Show, Tuesday nights from 6 to 8 on Studio B on Revolution Radio.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
And we're back with the second half of Geologic Evidence of Recurring Climate Cycles. The past is the... Go ahead.
It's irrelevant. How about that new bumper there? I was sort of hoping it was going to replace the Brian Roos bumper, but it didn't.
The creepy kindergarten. Nah, that freaked me out. Thank God it's radio. All right. Do you have any thoughts about what the media is doing and the disinformation campaign upon us?
I was just looking again back at that article about that garbage study, and I'm just flabbergasted at just how terrible it is. I mean, they basically claim in here now too that because their data using the cell wall thickness agrees with the climate models, well, it must be true. That's what they conclude.
And the climate models are off 500%, so it must be true.
It's completely crazy. I mean, again, like that is not science.
It's a way to get funding and keep getting funded. Our garbage study agrees with your garbage models. Can we have more money?
Right. And then it even says instead, both, this is a quote from one of the authors, I think, instead both show that the current warming is unprecedented, at least in the past millennium, and emphasize the role of greenhouse gas emissions on Scandinavian temperature variability. Well, okay, even if their data and their conclusions were correct, and even if it did agree with the current climate models, that doesn't inherently tell you that the reason for it is greenhouse gases. That does not point to what the mechanism is. That's another investigation. Like, that's not how science works.
There's not a single peer-reviewed paper that proves that greenhouse gases have affected the climate in any way.
Right.
That's a fact, Jack. Can you see the screen?
Yes.
Yeah, we're going to be talking about this paper, Holocene CO2, and the earlier IPCC reports. Now, here's what's interesting. The earlier IPCC reports used to use proxy data and actual science until it didn't fit their narrative.
Yeah.
And they had very clear graphs in all of their studies showing CO2 rising with the temperature dropping for 6,000 years.
Not only that, but they also recognized the role of obliquity in all
right
of
here.
this.
The purple line is obliquity.
Right. And they acknowledge it in writing as well in their reports.
Yeah.
But then they just shrug it all off like, oh, this isn't important.
The reason the Northern Hemisphere temperature graph has such extreme temperature variation is because of obliquity.
Right.
So
which also affects different parts of the globe differently, which is also reflected in the data.
Yeah, exactly. And so we're actually going to come over to NASA's explanation of Milankovitch orbital cycles and their role on Earth. What we have is a 100,000-year cycle, which is a change in the shape of the orbit, which gets more and less eccentric. That's called eccentricity. So over a period of 100,000 years, we actually go further away from the sun and closer to the sun. And this is what is believed to trigger those 100,000-year glacial cycles, or the 104,000-year cycle we see in the proxy data. So that is the eccentricity cycle. It's very visible in the sedimentary rock record, and most major boundaries every meter to 5 meters in sedimentary areas is this cycle being shown in a basin. So it affects the climate in a huge way on a 100,000-year cycle. And we know it based on ice ages. Then there's the axial tilt, the obliquity. And this is happening at the same time. All these cycles are happening at the same time, simultaneously. And it's this little change in tilt every 41,000 years that was displayed on that graph, which would in fact make some places warmer or colder depending on where they're shifting. Because you're basically rotating the Earth in a slight manner.
Right.
So if we're moving south here, we're going to get warmer. If we're moving north here, we would get cooler.
Right. Right.
And that would be that's the change in obliquity. And then we have the great year cycle, which is the axial precession, which traces out the astrological signs.
Yeah.
And all these are working in concert to create the title of this channel, Cosmic Catastrophe.
Yeah.
Yet we do not know why these mechanisms trigger catastrophic events every 12 and 26,000 years or so.
Mm-hmm.
And then every 100,000 years. It's not certain that this minor change, how does this change make ice ages? I mean, it's a very minor shift that gradually happens over 100,000 years. It doesn't just shift one day and we're in an ice age,
Right.
but that's what it shows up in the proxy data.
Well, I mean, what that suggests is really just the power of the sun, right? That it doesn't take that much of a shift to create major climactic change.
And the reason that these changes might be happening, what the tipping point is the weather patterns, the jet stream.
Mm-hmm.
So if the ENSO cycle shuts down, which is now running hard in our modern lifetimes, several thousand years, the pattern, the jets, you know how we have a meridional flow that brings all this wavy weather over the US? That wouldn't exist. There would be a weak jet up here, nothing happening, no weather, and all of the jets in the weather patterns would be down here near the equator, all the storms. It would kind of be an ice age up here and dry up.
Mm-hmm.
But in the pattern we're in now, the exact opposite happens. The ENSO forces all the liquid to drop on North and South America and dries up Africa, and then all of Central Asia. So it could be these changing ocean currents. You know, we could have the AMOC shutting down, could be triggering these ice age events during the slow, gradual shifts of things like eccentricity, precession, and obliquity.
Right, but these shifts, like let's say of the ENSO cycle, is related to, let's say, the obliquity cycle.
Yeah,
Isn't it?
and well, we can tell because of the graph.
Right.
There's a direct correlation between what's happening with temperature and what's happening with axial tilt.
Right. And so the trigger is probably it's insulation from the sun, right? Depending on how much insulation the Earth is absorbing at various parts on the globe, and then how that then affects some of these currents, let's say.
Yep. And there was a change in the last 2.5 million years. We were pretty much stuck in an obliquity cycle of rapid climate change, up and down every 41,000 years. And then there was a shift, and then the more pronounced cycle became eccentricity for the last million years, which is bad news because the 100,000 year warming is ended.
Yeah.
Which means we're going back down.
Yeah. Yeah.
And the next ice age has begun, whether you want to believe it or not.
Right. And it's not going to be like hugely abrupt, but it's going to happen.
No, it is not going to be hugely abrupt. Now, here you can see what the effects of that obliquity on different temperature graphs. This is the last 12,000 years since this is the end of the Younger Dryas and the rapid rise in temperature on Earth. It was 10 degrees here. But as you can see, the dark black is the northern hemisphere. It has a much more pronounced rise in temperature, which is the Holocene climatic optimum. And then something happens, and now we see a rapid shift downward.
Mm-hmm.
And this is during the neoglacial period. Now, what's interesting is that the southern hemisphere and the Arctic are more flat during this time. See this?
Mm-hmm. Yeah.
Which is proving the point that it's the northern hemisphere that's getting affected the most from this tilt, and that the other areas are actually getting a little bit warmer or staying the same because they're actually retaining the solar insolation or gaining even more.
Right.
Yeah, so thems are the facts.
Yeah.
Now, what's also obvious is that the northern hemisphere has been rapidly cooling since the end of the Holocene climate optimum.
Mm-hmm. You know what else is interesting about this graph is that in the Holocene climactic optimum, you do see bigger differences for different places on the globe, right? Which just sort of speaks to that idea that the obliquity affects how do I put this? How I'm struggling with my words here. The, help me out here. The differences in different areas on Earth.
Well, here at the optimum at negative 5,000 right here, 5,000 BC, it cools in the southern hemisphere where it's warm in the northern hemisphere. So you have opposite effects. Is that what you mean?
So you have like sort of less variability depending on, let's say, latitude when we're not in that phase of the obliquity cycle.
Yeah, and then here we can even see where the obliquity, everything cancels out here right at the mid-Holocene transition. This is where it all comes together and then one supersedes the other and it shifts.
Yeah.
And that corresponds with that curvature of the obliquity.
Mm-hmm.
Now there's evidence, we have direct evidence of this being true, and the climate 6,000 years ago and earlier was much wetter, let's say, in Africa. And in the last 40,000 years, there have been at least 5 periods in northern Africa when it was green and wet, and the other times it was desert.
Mm-hmm.
So climate and regimes can rapidly shift in short periods of time. I don't think people get that.
Yeah.
If it starts raining in the Sahara Desert and it rains for 14 years, plants are going to be there.
Yeah.
Lakes and rivers will form.
Yeah.
And then people will move there.
Which it just completely shifts everything geopolitically at the end of the day, right? Because when the climate shifts, that changes where you have to grow food, maybe what kind of food you're growing, where people are living, where they move to. It changes everything.
Yeah, it does. And it stayed green out near Lake Chad even to Roman times, because Romans went out to this region and found lush farmland and huge cities of, peaceful people, and nothing like that today.
Well, right. I mean, why else do you think that the Roman Empire expanded as much as it did? Like, why would they have expanded into regions that were not going to benefit them economically in some way? So obviously having farmland is part of that.
Well, and what also helped was the medieval warm period.
Yeah.
Oh, the Roman
warm period in that case.
Right.
Yeah.
Which is a longer period of warm. It's literally super warm. And even the cooling here during the Iron Age is still as warm as today. So there was not a lot of hardships. So this massive fall in temperature isn't necessarily the cooling that affected them, but the shift in climate, which dried up the region and shifted farming areas, literally, because this 1.5 degrees C shift, that's what eliminated the grapes from Britain.
Yeah.
Yeah. So if you're living on grapes and you can't grow grapes anymore, you are officially screwed.
Yeah. Yeah.
So
interesting to see too, like from this graph, that you could have been growing grapes in those northern latitudes for 2,000 years prior to that shift.
Which is why they might have been there, because they knew that they could grow there.
Yeah.
Yeah.
That's what I'm saying, right? Like why the Roman Empire would have no reason to expand in an area where they can't grow agricultural crops or benefit in some other way. Like they didn't just expand in order to take over groups of people. Like obviously you're going to do that based on how it benefits your empire.
Right. And we've done a podcast on why it got so cold here. It might have been a cometary impact and volcanoes simultaneously going off. 536, worst year to be alive.
Yeah.
And we've been struggling to do one here on the 1200 AD Dark Age.
Yeah.
But it's basically the same thing happening there.
Yeah, absolutely.
And we are overdue for another one happening soon.
Mm-hmm.
Because they do happen every 1,000 years. And guess what? I just reported on. There's a new dangerous asteroid that is spinning between the Earth and the Moon that they just discovered a few days ago. It's 600 feet wide.
Oh, dear.
So if that ever gets knocked off kilter, that will just be like 100 nuclear bombs if it hits a city.
Interesting,
and
too,
even
that we
the
just
odds are
noticed
it's going to hit the ocean, so we are even more screwed, because it will create a tsunami that can kill more people than it actually impacting a continent.
Yeah. Yeah.
Yep.
It's interesting too that we just noticed it.
And if it hits the ocean, we know what happens based on 536. It gets dark for years. It rains. It's the dark age.
Yeah.
Dragons fly around and eat babies.
Right. Well, like one of the things that we talked about in terms of 536, right, is that when you get this hit in the ocean, one of the things that happened was that a lot of calcium was released into the atmosphere, right, which is white and has a great power of deflecting sunlight.
Albedo.
Yeah.
It's like snow in the stratosphere.
Yeah.
It's not good news.
No.
So what we can see is that we have these regular cycles of warm and cold, and that the whole time, the last several thousand years, it's been getting cold. In fact, the inflection point is kind of right here at the mid-Holocene transition around 6,000 years ago. It started getting cold continuously. And it has, in fact, dropped about 2 degrees C since the Minoan warm, maybe up to 4 degrees C, depending on which proxy data you use. Here it's showing 4 degrees C from that Minoan warming.
Yeah.
How different the Earth must have been. The entire Earth was flourishing during these warm periods. And it just goes to show how many people perished here in this 536 plague era. It must have had, I would think, up to 80% of the population from the Minoan warm to the Dark Age was probably eliminated. And I think that's what the elites are going for.
Yeah.
They're just trying to finagle it, and they're
Well, it's funny, right? Because there is this obviously huge focus on depopulation in some way, and there's so many efforts towards that, it seems, and yet they probably don't need to do anything, which is funny.
Yeah.
And that the theory that they push about global warming would traditionally inherently increase human population. So it's funny that they push a narrative that goes against the conclusion that they're going for, the objective.
Well, but it's easier to scare people.
Sure.
Yeah, because the model currently isn't that CO2 causes cooling, it was causes warming, so that's their narrative. They have to stick with that.
Well, and it's been the narrative for decades now, right? Like, let's say in general population since the 80s. So you now have a huge segment of people people like me who grew up with that narrative, and you. And so it's easier to convince people that we have a major catastrophe because they've been living with this concept of global warming for so many decades.
But the coldest it's been on Earth is just a few hundred years ago. Literally.
Right. Right.
But
most people don't know that, right? We don't teach that. I mean, I didn't learn anything in secondary school about solar minimums, that aren't that long ago.
Yeah. And the lowest CO2 is also recently during the Holocene.
Right.
The lowest CO2 ever on Earth since the Earth.
Which is what, two something?
It got down to 200 parts per million.
200, right? And we have big problems if we get down to 150 parts per million.
Well,
right?
170, 180 is the death of everything, I think.
Right. Plants stop growing, and then that's the end of everything. So sitting at 400 or so, or 450 parts per million is actually not very comforting. That's pretty close.
And what people don't understand is a 1 or 2 degree rise since the coldest time in the Holocene, the Little Ice Age. It's very easy to say it's warming. Oh, yeah, because it is.
Right.
Pick the coldest time. The only thing that happens after the coldest point is warming.
Right.
But what they don't tell you is it's not significant based on all the other warmings that have happened in the recent past.
Yes.
Where's my graph? Right there.
Yeah. Right.
So this is real climate change.
Yeah.
This is on a scale of 5 to 10 degrees C here. Not 1 degree or 2 degrees Fahrenheit.
By the way, on this graph here, where we have this sort of unexplainable shift where we have a 41,000 year cycle and then what becomes like a 100,000 year cycle, it makes me think that we must have had some minor shift in the let's say the mechanics of our solar system, Right. So slight shifts in obliquity changes, because I mean we're looking at what the obliquity changes and the eccentricity changes really are, and they're very minor, but they have a huge impact on the amount of solar insolation that reaches Earth. And so it's probably a small shift in that changes these cycles.
Well, and like Valentina Zarkova shows in her work about the heartbeat of the sun, there's millennial scale shifts. Maybe there are million-year cycle packages, and we're looking at those phases here.
Sure. And then if you throw in too, let's say Earth expansion, right? If you throw that in, like obviously that's going to have some effect on obliquity and eccentricity.
Exactly.
Yeah.
And so this is what should be taught in schools. And in fact, we had some great independent authors a few decades ago that were actually independently researching the actual paleoscience, using the proxy data, and warning the public that we are at the end of the interstadial, and that it is grand solar minimums and ice ages that control empires, not CO2 and humans. And a great paper, this is a little wishy-washy because he does use global warming in there, but he also talks about natural cycles. And you can get the free book if I'm going to link this below. You just click on view full text here, and you will get the full text of Ice Age Reentry by Carlton Brown.
But when he talks about global warming, is he talking anthropogenic global warming or just warming?
Natural. The world will face natural climate change related risks during the current grand solar minimum. And it says risk dismissed or ignored by the IPCC. And so he goes on to talk about the solar science and the stuff we just talked about, which is, well, I didn't show the longer time scales. I didn't show any of the charts with the 100,000 year cycle, but we did discuss the Milankovitch cycles. So what's also interesting is that I got this data set from today. This is on the tweeter. We are now at the boiling stage of the climate scam. It's boiling so much that Greenland ice coverage is now trending above the 1981 to 2010 average.
Yeah.
And this is during the melt season. So this is yesterday's data point. And for all of July and half of June, remember July is the hottest July on Earth. Greenland was losing ice slower than it has in the last 40 years. That makes no sense.
And also, isn't the Antarctic ice extent above the mean as well?
Well, Antarctica is at a very low reading, but the data set we have for Antarctic ice is only 30 years old. So it's meaningless because the Arctic ice maximum was 2012 to 2016, somewhere in that time frame, which was the most ice ever I'm saying Antarctica. I thought you said Antarctica.
I did talk about Antarctica. I thought that Antarctica ice extent was above the mean currently.
No, it's low. It's low, but it's a 30-year data set.
Right.
And the highest ever recorded was a few years ago.
Right. Okay. Gotcha.
So it's meaningless.
Right.
It's another cherry pick. It's low. It's so low. No, we just came off the highest ever during the middle of global warming.
Right.
So it's like the data sets don't make any sense. Arctic ice is at 10-year high. And then the normal alarmist thinks the Arctic is melting.
Right.
It melts every summer and then it freezes every winter.
Right.
Yeah. There is no evidence of decline of ice in the Arctic. There's evidence it's been increasing for 10 years. Bless you. All right, so let's sum it up. We've got 5 minutes, and you usually can come up with some amazing summary here.
Oh, you're putting the pressure on, huh?
Well, the point is there's evidence for massive climate shifts that happen every 1,000 years. We are now experiencing the massive warm up from the last ice age. And what happens when it peaks on every instance in the last few thousand years? After it peaks, it goes straight down.
Funny how that works.
There's no instance it doesn't go straight down here on the graph.
Yeah.
So at some point here, we're done and it gets cold very rapidly.
Yeah.
And in many cases, it's triggered by grand solar minimums. When the sun shuts down, sometimes objects hit the ocean. Sometimes there are VEI 6 or 7 eruptions.
Mhm.
We're overdue for a VEI 6 happening any day, in my opinion.
Yeah. Well, and the other thing too is what Xavier here points out that what he uses the term like thermal inertia as well, right? So it's like, obviously the Earth has thermal mass; it can hold on to heat, and so there's a point at which and you can sort of probably see it in these peaks where we get to some point where we sort of overcome the inertia, let's say, of warming, and then we fall into a cooling phase. And so while the next ice age may not be really abrupt, in some way it is, because the start of it may be abrupt.
Oh, excellent. You did it. Maybe next week we'll talk about the shutdown of the AMOC and how that may be the trigger. Be safe. We love you.
You're listening to Revolution Radio at freedomslips.com. And we'll be right back after this message.